Okay, yay, we only have 6 slides left in this PowerPoint, so let's go ahead and wrap this up. So remember, heat can kill microbes because you're going to irreversibly denature the enzymes, but cold won't, okay? In fact, freezing cold temperatures actually helps preserve especially bacterial cultures. So 2 terms I want you to know. Desiccation is basically when the cells just dry out. Like, think of an agar plate that you have bacteria growing and you just let it sit out in room air. Eventually it's going to dry out. That's what desiccation is. Lyophilization is a fancy word for freeze drying. And freeze drying is actually the way that a lot of bacterial cultures are preserved, because if you suck all the water out of it and you keep them at cold temperatures, they don't care. They are fine. And then once you put them back in media and bring them up to a normal temperature, they're back at it, okay? So the important thing is that cold does not kill microbes. You can only kill them or inactivate them in the case of viruses and prions with heat. Okay. Another common disinfection technique is using ultraviolet radiation. So this is used in water treatment plants to help treat drinking water. It's also used, there's a little robot actually called Trudy that's used in a lot of medical offices, and it cruises around and shines UV light. And it's a way to disinfect. So many microbes are sensitive to excess ultraviolet radiation. And so they will die when they are treated with that. But once again, it's not sterilization. It is used for disinfection only. Okay, so when you choose a chemical that you're going to use, let's say that you want to treat a patient room, and so you want to disinfect bed rails and the floors and anything that a patient might touch. There's a lot of considerations, and really a lot of them are common sense. Okay, you would love for it to be soluble in water and be able to dilute it, and so that it has, good and rapid action even in low concentrations. You would like it to be able to have broad spectrum microbicidal action, meaning that it's going to kill a whole bunch of microbes, but it's not going to be toxic to human tissues. Because what good is it if it, ends up killing the person who's actually applying it? So you want it to be non-toxic. You want it to be able to penetrate that inanimate surface to the point where you can actually destroy microbes. If there is things like, soap scum and dirt on the floor, you still want it to work. You don't want it to eat away things, so be non-corrosive. You want it to smell good. And probably the biggest thing when we're talking about healthcare is you need to be able to have access to it, and it needs to not cost $1 million. Okay, so those are the things that healthcare institutions look at when they're choosing, okay, what kind of chemicals do we want to use to be able to disinfect patient rooms, but also this goes for antiseptics as well when you're talking about betadine and chlorhexidine. If they're going to eat away the patient's tissues, they'll kill microbes, but they're going to hurt the patient. So there's a lot of different things to consider. So factors that can affect whatever chemical you're using. First of all, what are you trying to get rid of in the first place? Is it just bacteria and viruses? Or are you trying to get rid of prions and cysts and endospores and things that are much harder to actually destroy? You need to think of the nature of the material being treated. And what I mean by that, are you dealing with human skin and you want to do antisepsis? Or are you talking about inanimate surfaces and you can use a disinfectant, which can be a little stronger? How contaminated is the surface that you want to disinfect? How much time is it going to take? If the chemical has to sit there for 24 hours, that's not going to be very labor or cost efficient, because once a patient checks out of a patient room, you want to be able to get in there, disinfect it, make sure it's safe, and then let someone else check into that room or be admitted to the hospital. Okay, and then also what exactly is it doing and how strong is it? Can you dilute it, which makes it more cost effective? So a couple of other compounds that have been used are heavy metals such as mercury, gold, silver, and zinc. Right now, the only ones that are used still in germicidal or microbicidal chemicals are mercury and gold. Okay, but there are drawbacks to this. People can be very allergic to these metals. They can be very toxic. We know that heavy metals can affect your liver and kidney function. And also, microbes can develop resistance to them. So we don't want that to happen, right? We don't want to use these chemicals that are potentially toxic to humans and then they're not going to kill the microbes anyway. But I wanted to show you an example of these. So this are little pieces of silver right here and a little piece of gold. And they've inoculated a plate with bacteria. And you can see there are these clear zones that are occurring around the little flake of silver and gold. And what that means is that the microbes and the bacteria are being inhibited. So they're not able to grow because the heavy metal is leaching out into the agar and it's preventing bacterial growth right around where you have the highest concentration. So they do work against microbes, but the other considerations that I just previously mentioned, like being toxic to humans, we have to consider that. Hey, look at that, we're done. Okay, yay. So that is the end of chapter 7. Listen to these videos if you want, and it'll help you with the chapter 7 assignment, which is worth 50 points. Okay, thanks guys. Thanks for listening.